Hi everyone, welcome to my YouTube channel. In this video I am going to explain you about differential equations, one of the important topic from mathematical method of physics. The students, those who are preparing for KSET or NET exam, this topic is very helpful because compulsory questions will come from this topic. So let us discuss. First definition: an equation which involves differential coefficient is called differential equation. Example, dou y by dou x is equal to x plus sin x. So another example you can see here, d by dx is what? The differential coefficient. So the classification, if you want to see, two types are there: ordinary differential equation and partial differential equation. So order and degree of differential equation, one of the question will be from order and degree of the differential equation. So the highest order derivative present in the given equation is known as order of differential equation. The power of the highest order derivative term present in the given equation is called degree of the differential equation. So these two definitions, if you know, you can clearly solve the questions on order and degree of differential equation. So linear differential equation, if every dependent variable and its derivative occur in first degree only, and another condition is no products of the dependent variable and its derivative occur. So here dependent variable is y and independent variable is x. So if these two conditions are satisfied, we call that as differential equation. Here linear differential equation, you can see the example given here. So differential equations of first order and first degree. So we have differential equation of second order and second degree also. So the first order and first degree. So as I said, the definitions of order and degree I have explained. So in first order and first degree differential equation, case 1, separation of variables. So the question they may ask from this section, every differential equation we can write in terms of f of x dy is equal to phi of x dx. So we can integrate these two equations. So then you are going to get the solution of this equation. So example, if we have exponential dy by dx equal to x plus 1. So first you can take the log on both sides and represent in terms of d by dx, it is equal to ln x plus e. Then you can separate the two terms, the f of x, and if you take dx to the LHS side, RHS side, then you can write ln x of x plus 1 of dx and take the integration of both the functions. Then you can solve. So like that you can solve the problems related to separation of variables. So case 2, the questions may be from homogeneous differential equation. A differential equation dou y by dou x equal to f of x comma y phi of x comma y is said to be homogeneous if these two functions are same degree. The degree of the functions must be same. So in such equation we can put y equal to u into v, dy by dx is equal to differentiation y plus x dv by dx. So example I have given here, let us take this example, x dy minus y dx they have given equal to root x square plus y square dx. First you should convert into dy by dx, and then once you convert you are going to get y divided by x plus root of 1 plus x square y divided by x whole square. So this is nothing but in the form of this equation. So then you can solve the this equation. First you should convert these equations, whether it may be separable of variables or homogeneous differential equation. After making them in the standard form, you can solve the given equation. So the case 3, the questions may be from linear differential equation of first order. So first order, that is the derivative dy by dx, it is having the order 1 and degree also 1. So here p and q are the functions of x, and solution of such type of differential equations is given by integral factor into y, integral q of x into integral factor dx plus c. So integral factor here it may be that is equal to e to the power p of x dx. So if the questions are from this topic, then you can solve here. Example, here you can take dy by dx minus y divided by x plus 1 is equal to e to the power x plus 1. So first you should mention here which is p and q, then take the derivative, integral of this p, that is integral factor of e is equal to e to the power root integral of p of x dx. Then you can solve the given problem. So the case 4th is exact differential equation. So here the differential equation is of the form m of x plus y dx plus n of x comma y, that is equal to 0. The exact nature of this equation is dou m by dou y is equal to dou n by dou x. Differential of these two parts are going to be equal. So solution, how you can write, integral of m dx plus n dy is equal to c, but if you take integral of m, taking y in m as constant, if this m consists of y, this y you can consider it as constant and differentiate with respect to x, integrate with respect to x, and take only those terms in n which don't contain x. So here if n consists of x terms, you should neglect them and integrate with respect to y. So let us take example here. This is m, you can consider, and this is n, and take the derivative, that these two derivatives of m and n must be equal, and solve the equation. So linear second order differential equation, case 1, that is homogeneous differential equation, that means the second order differential equation is equal to 0, that is homogeneous, and pq are here constant. So the trial solution of this equation, let us take y equal to c into e to the power mx. Then the solution or the auxiliary equation we can write like this: m square plus pm plus q is equal to 0. So here some conditions are there. If depends upon m1 and m2 roots. So m1 and m2 are real and equal, then equation is going to be like this: y solution y equal to c1 e to the power m1x plus c2 into e to the power m2x. If m1 and m2 are real and equal, you can take the coefficient c1 plus c2 common e to the power mx. If m1 and m2 are complex, you can write the equation like this. And if m1 and m2 are complex conjugate, let us take m1 and m2 alpha plus I beta, then y is equal to e to the power alpha x a cos beta x plus b sin beta. So these conditions you should follow for solving homogeneous differential equation of second order. So case 2 is non-homogeneous differential equation of second order, that means this differential equation is not equal to 0, it is having some function r of x. So here you can write in terms of this equation, let us take d as d by dx, capital D, then you can also represent the equation in this form. So the solution of this second order non-homogeneous differential equation consists of two parts. First one, complementary function, as we have observed in this homogeneous differential equation. So it may have the two roots and you can represent in terms of the solution. So second, partial integral depend on the form of the another function r of x. So particular integral and complementary function. So the solution of the non-homogeneous differential equation consists two parts are there. So first part you can easily do it. Second part that is to have the partial integral. There are some rules to get the particular integral. So first rule is if r of x is equal to exponential function, then the particular integral is equal to 1 divided by f of d is equal to e to the power x, that is equal to 1 divided by f of a e to the power x. So these rules if you follow, you can solve the non-homogeneous differential equation of second order. And in this case, if exponential function, so the first one f of a is equal to 0, then particular integral you should represent it as x into 1 divided by f of a e to the power x. So many of the students may face difficulty solving non-homogeneous differential equation because it consists of two parts, particular integral along with complementary function. So particular integral, if you want to solve, you must know these formulas. Okay. So the second rule is if f prime of a is equal to 0, then the particular integral is equal to x square 1 divided by means second order derivative of function a, f double prime a e to the power ax. So the second condition, r of x, polynomial of x. If this function is polynomial of x, then particular integral you can represent it as 1 divided by f of d x to the power n. So expand 1 divided by f of d in series. So r of x cos ax or sin ax, then particular integral is going to be 1 divided by f of d square sin ax. That is equal to 1 divided by f of minus this a, whatever it consists, minus a square sin ax. So here another condition, if f of minus a square is equal to 0, then the particular integral is x divided by f prime of minus a square sin ax. So r of x e to the power alpha x phi of x, if the function is like this, then the particular integral is going to be 1 divided by f of d e to the power x phi of x as it is, that is equal to e to the power x 1 divided by phi of d a plus a. Whatever the a term is there, you should add in the function d plus a of phi of x. So these are the rules you should follow to solve the particular integral for non-homogeneous equation. So some question, sometime they may ask Cauchy-Euler differential equation. So this is Cauchy-Euler differential equation you can solve. But singular points and ordinary points also they may ask. These are for 5 marks sometime in CSR net exam, and for 1 or 2, 1 marks or 3 marks they may ask. So that time you should know these rules. So singular points and ordinary point, this is second order homogeneous differential equation. So ordinary point, if these f of p of x and q of x are finite at x equal to x naught. Singular point, if functions, if the constant p of x and q of x are infinite at x equal to x naught. There are two types, regular singular point and irregular singular point. Power series method for ordinary points you can use, and Frobenius method regular singular points. So special functions, another type of differential equations are the special functions. Compulsory among these four, one question will be there for KSET exam, or for the net exam they may ask for the solutions related to these equations. So that time these formulas are very helpful. So the Legendre differential equation, this formula you should remember. 1 minus x square dou square y by dou x square minus 2x dy by dx plus n into n plus n minus 1 y is equal to 0 n plus I. Bessel differential equation, x square dou square y by dou x square plus x dy by dx plus x square minus n square y is equal to 0. Then Hermite differential equation, dou square y dou x square minus 2x dou y dy by dx plus 2xy. Lugare differential equation, n into d square y by dx square plus 1 minus x dy by dx plus ny. So if you observe these four equations, sometime you may get confused. So that's why you need to practice and write all the four equations unless and until you become thorough about that. So these are very important special functions: Lugare, Bessel, Hermite, and Legendre differential equation. I hope this video is helpful for you, and in this video I have explained you about all the differential equations that they may come in exam, and exactly how the questions they are going to ask from this topic and how you can prepare. So in the next video I am going to solve problems related to each of the special topic that I have discussed: differential equation of first order and second order, also special functions. So this is the brief introduction or the explanation about differential equation. So exactly you should know what they are going to ask from this topic, differential equations.